welcome everyone to the fourth webinar in the series of Animals, Climate Change and Global Health. My name is Angie Pepper. I am a philosopher at the University of Roehampton. My research interests are in questions to do with interspecies justice. So I'm interested in what animals are owed as a matter of justice and the normative significance of non-human animal agency. So what do animals do and why does it matter for how we should treat them? It's my great pleasure to be moderating today's session on animals affected by climate change. I'm not going to say too much now. I'm just going to introduce our experts who are going to be talking to us about some of the ways that animals are affected by climate change and also how they're affected by human responses to climate change. So our first speaker for today is Jonathan Lovvorn. Jonathan is Faculty Co-Director of the Climate, Animal, Food and Environmental Law and Policy Lab at Yale Law School, which develops innovative legislative and litigation strategies to address animal, human and environmental exploitation within the global food system. He teaches courses on animal law, wildlife law and climate policy, and has published a number of articles concerning the intersection of animal law, environmental law and food policy. He previously taught courses on animal and environmental law at Harvard, Georgetown and NYU, and served as the policy director for that Harvard Animal Law and Policy Program. He also serves as the Chief Counsel for Animal Protection Litigation at the Humane Society of the United States, as a senior legal advisor to the San Francisco SPCA's Shelter Policy and Legal Services Project, and on the board of Director of Wellbeings, a new nonprofit developing innovative solutions to protect animals, people, and the environment. So Jonathan is going to be talking to us about animals and the climate crisis. Jonathan, the floor is yours.
Thank you so much. So I'm going to give a more general overview of this issue, and then we're going to have two terrific presentations of more detailed areas of it. I'm going to talk a little bit thematically about where animals sit in the climate crisis, and in particular, how animals are a lot of the frontline victims of the climate crisis and how we can learn something about humans and climate by looking at animals and climate. And if anyone's wondering about this contraption, it's actually a canary resuscitation device from the 18th century. Rather than putting canaries over and over in the coal mine and having them die, they would open up the door, and when the canary ran out of oxygen, they would resuscitate it. Maybe a humane device, but maybe just a canary cost-saving device. Okay, so in case you've been completely oblivious to the news or on a long sea voyage without internet, we're getting an increasing number of dire reports about the crisis with the climate. And in particular, they fall into broad categories, which is too much water, including sea level rise, in particular in North America, tens of millions of people living within 3.3 feet of the high tide mark, and then not enough water. Huge areas that are going to run out of water or are already running out of water, and increasingly strong storms. This piece in particular caught my attention because it was one of the first studies to actually make a connection between an individual extreme weather event and climate, which is a difficult connection to make most of the time. But in the same media coverage of this, there was a lot of connection between humans and animals. And certainly what happens with humans in disasters happens with animals in disasters as well. So I also highly recommend this piece from the New York Times Magazine that talks about the impacts of climate migration. And you may think, well, what does that have to do with animals? Well, obviously, what happens in human migration carries over, especially in particular with companion animals. And this question about both emergency displacement and long-term displacement is going to increasingly become really important, and particularly with animal policy, which I'll talk about more in a minute. Overall, we think maybe 13 million Americans, I've seen estimates as high as 20, will have to relocate within the next 10 to 15 years. This is going to be an extraordinary event with regard to human-animal relations. And the important thing to think about is that, and I argue this in the first paper that I wrote on this topic, that these impacts are not equal opportunity impacts, right? So the impacts of climate fall hardest on the most vulnerable members of our society. And that means vulnerable populations of humans, but in particular animals who lack the agency that humans have. They're not able to adapt as well. They don't get the news. They can't pick up and move. And so what we see happening with animals is a precursor to what we see happening with humans. And we saw this early on in Hurricane Katrina, which was a watershed event within the animal protection community. When they looked at the data from Hurricane Katrina, the first indicator of whether or not you died in Katrina was economics, whether you could afford to get out. The second indicator was race, and whether you died in Katrina. And the third, which is less talked about, is whether or not you had companion animals and whether you stayed behind because of those companion animals. So this connection between humans, animals, climate, health is really fundamental. And that really shouldn't surprise anyone, because the connection between humans, animals, energy, climate, civilization goes back to the beginning. We literally formed civilizations by following herds of animals to hunt. And then ultimately, the domestication of animals and agriculture is the foundation for civilization. So this interrelationship is really fundamental. We used whale oil for heating and energy, and horses for our primary mode of transportation for thousands of years. And it's generally accepted as doctrine within the animal protection community that things like the discovery of petroleum and the invention of the internal combustion engine were good for animals, that this liberated animals. This is a woodcut from 1861 where the whales are supposedly celebrating the discovery of petroleum. We actually saw a very different outcome from that, but I'll talk about that more. But this idea that petroleum, and particularly internal combustion engine, is a positive for animals turns out to be somewhat apocryphal. So we've seen the direct impacts of the switch to the fossil fuels from animal energy. But it's also the indirect impacts that we have to think about. And long term, we may see the idea of switching from animal power and animal energy to mechanical petroleum-based combustion energy as a huge net negative for animals because of the impact of these emissions. And again, I just want to emphasize, in all of this, animals go first and are the front line of the impact of these emissions. Okay, I'm going to talk about wildlife for a minute, just an overview for any of you who don't have a background in this. We see discussion of we're in the 6th extinction, we have 1 million species at risk. We need to think about, what does that actually mean? Well, it's important to realize that this isn't just a case of climate change is all bad for animals. Some species will benefit from animals, other species will not. A lot of species will migrate. Animals are migrating towards the poles. Trees are even moving towards the poles at a measurable rate in order to try to adapt. But there are barriers, whether it's border walls or other human-made barriers or mountains or rivers. There is some limit to how far terrestrial animals can adapt. And this is particularly problematic in the oceans, because most of the warming energy is going into the ocean, and those animals can't perceive those changes the same way terrestrial animals can. And so as a result, we've seen a fair number of unexplained die-offs and an increased number of die-offs. The impacts in the oceanic community, we're just beginning to understand what they might actually be. And I know we'll hear more about that today. So we also see terrestrial events. I usually use this as an example of a terrestrial event, not to shock anyone, but this event in 2015 where 200,000 endangered sheep just died one spring. And when they looked at the data from this, what they discovered was that a slight increase in temperature that spring caused normally benign gut bacteria in these animals to become toxic. And so you have this sudden loss. So what does this tell us? What it tells us is some species are incredibly vulnerable to climate change. Others are not. Some will adapt, others are not. And in most cases, we won't know species are vulnerable to climate until it happens. And so this is very scary, because we don't really know what's going to happen or where it might happen. Okay, this is kind of depressing, but let's take some numbers. So This meta-analysis of species loss from climate change estimates maybe 16% at business as usual trajectory, which sadly that's where we're headed. But even if we held to 3 degrees, we're talking about 8.5% of species, which is an enormous number of species. But from an animal welfare perspective, how do we even translate that? Well, we know that most mortality events are not species level extinction events, right? So we have a huge number of mass mortality events for every extinction. There's going to be many more of these massive mortality events. So the impact of losing 15% of species is really, from an animal welfare standpoint, way beyond the loss of those species. And we're talking about millions or even billions of animals in order to get to that space. But again, we really have no data and don't know. In one of my papers working with a conservation biologist, climate biologist, I extrapolated maybe 147 billion animals over 20 years, which is incredibly speculative number. The footnote for this goes on for a page. But if you tried to amortize that out over 20 years, you're talking about maybe 7 billion animals a year, which other than factory farming, dwarfs any of the other common animal mortality sources that we work on. I had to adjust the chart just for these other issues like trophy hunting, research, and wildlife trafficking to show up on this particular chart. And so this isn't normally talked about. I mean, when you look at typical information about species loss, climate change is way down this particular list, particularly with regard to the red list data. So why is this? Why does climate change come in so low? Well, it's about the way we keep track of species, right? So ultimately, a few thousand species are assessed on the red list. And this is a tiny little snapshot of the totality of species on Earth. It's more like, 8 or 9 million species. So when we talk about a slide like this, where climate change is only a small number, that's because it's a small number of the 8,000 or so threatened or near threatened species that are actually assessed. So there's this huge amount of wild animal mortality over climate that is outside our normal discussion. We have the Endangered Species Act. What's the Endangered Species Act about? What does it do? Well, ultimately, it's supposed to stop these extinctions from happening. But most observers, including the people charged with implementing the statute, recognize now that the tools associated with traditional conservation environmental law are fundamentally incapable of tackling this problem. And I don't have time to get into it now, but increasingly it's recognized that these tools will not be able to stop the extinction crisis with regard to climate. And part of the problem is one of the biggest issues is environments are becoming no longer hospitable to the native wildlife. So we're faced with sort of move it or lose it situation that is increasingly difficult to cope with, because one of the fundamental tenets of conservation biology is not to move species from their native habitats to non-native habitats. But we need to talk about what ultimately happens when the only remaining choice is to move a species from its native habitat to a non-native habitat. What does that mean for the animals that are still in that habitat? And what does that mean for conservation biology when one of the most fundamental tenets is no longer applicable? All right, I want to talk about other animals quickly before handing it over, and particularly companion animals. There's less known about companion animals than wild animals. We have seen, reports of impacts from storms. This story really struck me. This cinder block facility that was supposed to protect animals from a coming hurricane was reduced to rubble. Remarkably, all the animals got out. Other stories, Hurricane Katrina, 60 to 70,000 household pets lost. It goes on and on, story after story about animals in these events, but we don't really have any data or numbers about the losses. We know climate affects pet health, including increasing vectors moving into areas that they weren't originally located in. As we get warmer and wetter, these diseases become more problematic in more areas of North America. Heat waves, we've seen discussion about this. I won't belabor it. You know, situations with, you know, deaths. It's really remarkable that the Obama climate assessments predicted that human heat wave deaths will exceed gun deaths in the United States by 2030. We don't really talk about this stuff. And of course, I don't have time to get into the whole situation with wildfire, but in particular in the West, this has become a huge problem. Again, no data that I'm aware of yet on how many animals are we losing because of the impacts of climate in these particular spaces. So I think I'll stop there and unshare, and we can move on to other presentations. I might come back to some of these slides if questions are raised in the Q&A space.
Brilliant. Thank you, Jonathan. That was a really informative overview of some of the issues that we're interested in today. So the second panelist is Irus Braverman. Irus Braverman is Professor of Law and Adjunct Professor of Geography at the University of Buffalo, the State University of New York. Her research focuses on the relationship between law, science, and nature. Braverman's books include Planted Flags, Trees, Land and Law in Israel and Palestine, which was published in 2009, Zooland, The Institution of Captivity, which was published in 2012, Wildlife, The Institution of Nature, which was published in 2015, and Coral Whisperers, Scientists on the Brink, which was published in 2018. Her latest monograph, Zoo Veterinarians, Governing Care on a Diseased Planet, highlights the recent transformation that has occurred in the zoo veterinarian profession during a time of ecological crisis, and what this transformation may teach us about caring for a diseased planet. Braverman is currently writing about the management of national parks and nature reserves in Palestine, Israel, with a forthcoming manuscript entitled Wild Legalities, Managing and Imagining Nature in Palestine, Israel. She's also conducting research about One Health and the medical post-humanities and on ocean legalities. She's also edited several books and collections and special issues on legal geography, gene editing and the environment, and ocean legalities and environmental justice in the occupied Palestinian territories. So Irus is going to be talking to us today about coral conservation, from polarization to correlation. Irus, the floor is yours.
Thank you so much, Angie, and thanks to all of you for joining us today. So I'd like to share a few thoughts about the book that I wrote that came out in the end of 2018. And the book is called Coral Whisperers. And I'd like to also move beyond Coral Whisperers and its framework to think about correlations. And so this is the concept that I'd like to kind of to reflect on with you guys today. So the book documented from the perspective of some 100 coral scientists and managers how the scientific community has been dealing with the massive coral death around the planet. And I've been documenting the oscillation of their approaches between despair and hope. So that's kind of how the book is structured, from despair and hope. And I claim there that this is very much a characteristic of doing conservation and being somebody who's environmentally minded in the Anthropocene, right? This kind of oscillation between hope and despair. And at the same time, I also claim that this also represents the oscillation between traditional approaches to conservation, which Jonathan kind of mentioned some of them in terms of preservation and non-movement, et cetera, to more interventionist and say new approaches to conservation management. So I think that there are some interesting correlations here between these different binaries. So I'm going to start this presentation by presenting this binary approach, and then I'm going to offer a way out of it, perhaps, and hopefully we'll think about it together. So I conducted my research for the book between 2014 and 2017. And those of you who are familiar with coral conservation know that these have been very important years in that context, because as it happens, and I didn't really plan it that way, it exactly fell on the years of what is called the third global bleaching event. And this is the longest recorded bleaching event in history. And it hit the reefs in the Great Barrier Reef particularly hard. So you can see here some images from the bleaching of the world's largest living structure, which some scientists have said have become the largest dying structure. So what is bleaching? So for that, we need to go just a tiny bit into the biology of corals and to understand that a coral is a holobiont. It's an amalgam of animals and algae and bacteria and viruses. Specifically for our story, I'm going to focus on the symbiotic relationship between the animal and the coral animal and her symbiotic algae, which is called also symbiodinium. And when there is a warming that causes the coral animal to expel. Some say that actually the algae is the one who's doing the expelling, so questions of agency abide in this context. But here you can see the process whereby a healthy coral turns into a stressed coral when the algae departs from the body of the polyp, of the coral animal, and becomes a bleached coral, which I want to highlight is not a dead coral, not yet at least, but it's a coral that is more vulnerable to becoming dead. So here are some images from bleached corals, and since the 1980s, there have been almost annual events of such bleaching mortalities that have, or bleaching events that have ended up in mortalities that have happened almost annually, but only on a local scale. Now, where the global scale enters in is at the end of the 1990s, when a new type of bleaching event has been identified, and this is the global bleaching event. There have been 3 events thus far. Global bleaching event means, is defined, at least by NOAA, as a mass bleaching event of at least 100 square kilometers in all 3 ocean basins. So here are some images from events. You can see a bleached coral on the left, a dead coral on the right. And I just want to say that to kind of chime into Jonathan's canaries in a coal mine. So corals are often depicted as the canaries in the coal mine here because of their sensitivity. The sensitivity of their particular relationship to the rising temperatures means that they are like, they're screaming at us when there's this warming of like, yes, now we're bleaching, we're suffering from this event. So this warming translates into the reaction in the body of the corals, becoming a sign for perhaps what will then become the collapse and the death of many other organisms in the oceans, because corals are also ecosystems, and they are responsible for 25% of the diversity on the oceans, and are called the rainforests of the oceans for that reason. So as Jonathan was highlighting, there's a strong correlation between these animals' health and human health. 500 million humans depend on corals for example, for food or for protection from storms, et cetera, and I can speak a little bit more about that later. So coming back to my coral scientist interlocutors, these are the people I spoke about to document how they're dealing with this spectacular and massive death. And Terry Hughes, who is one of the leaders of the efforts to document the recent bleaching events in the Great Barrier Reef, this is what he tweeted during the global bleaching event. And then we wept. And so just wanted to highlight the emotional aspect here of this statement by the scientist, right? It captures kind of the existential crisis that is undergoing in the scientific community of humans who also have a relationship and an emotional relationship with the non-human animals that they are working with. And indeed, many coral scientists have kind of taken to despair, gloom and doom as they call it. And a lot have claimed that coral reefs are doomed, and that nothing short of an abrupt and perhaps unlikely shift in how we use fossil fuels will save them. And here are some of the statements. This is the IUCN index. The latest one I could find, actually, I think was from 2009, which is strange enough. But you can see corals really taking a big decline here in this graph in relationship to even to amphibians, who have also been very impacted by climate change. So Professor Hugh Goldberg has told me the Titanic is sinking, and what we are doing is rearranging the chairs to get a better view. So this was at least at that point of the interview, his approach toward what restoration biologists are trying to do, rearranging the chairs. He really feels, or he at least felt when we spoke, that the major work needs to be on the global level in stopping climate change. And these tweaks are not as impactful or important when the environment is changing, and so restoration is less significant. And so what's the point in returning corals into the same environment where they're going to bleach and bleach and bleach again? In fact, it's cruel. So, however, I'm going to now move to the other side of the pendulum, telling a few stories of hope. And this has been something that has started to become pretty significant. Some of you might be familiar with ocean optimism and this approach of active hope that some scholars have recently been highlighting in our way to move beyond despair and to find a way to stay active in the face of this doom and gloom, right? And so these narratives of hope also have resonance and implications on the ground. And I'd like to speak a little bit about coral restoration through nurseries and through other methods, such as assisted evolution. So here, Nancy Knowlton, who's a coral scientist and one of the founders of ocean optimism and that approach, who says bleaching is bad, but giving up is worse. Okay, so coral restoration. What is coral restoration? This is a practice of actually cultivating and transplanting corals back into the damaged reef. And some have suggested to call the two-step process of, on the one hand, growing coral fragments and then transplanting them, coral gardening. There are massive projects of coral gardening that include using nursery cultivation and transplantation to restore devastated reefs, and also to eliminate so-called pests and so-called invasive species, such as the crown of thorn starfish that you see here that kind of latches on to corals and sucks the nutrients out of them. And so there's massive extermination projects for this crown of thorn starfish in Australia. You can see here the use of the cot's butt to inject salt into their bodies to kill them. And then there's massive culling projects of the so-called invasive lionfish. And I'd like to also focus on the making live, not only of the making die of this story, and that is these different coral restoration projects, which include locations selected for ecological significance, sometimes creating artificial reefs, such as the one that you see here in the picture that I was diving at with my daughter. And this is in the Red Sea. So this is an artificial reef so that the tourists don't destroy the actual reefs. Okay, let's attract them here so that they can leave alone the real coral reefs. And then there's many projects that are kind of that target tourists, come and restore a reef, plant your own reef, sponsor a concrete coral frame and have your name engraved on it. So these are some of the ways that coral restoration is happening. And coral restoration projects vary not only in geography, not only in aims, not only in target species, but also in their technique. And here in the image, you can see a shot that I took in Puerto Rico, I believe it was in Vieques, of scientists working with metal structures and planting the corals, the Acropora corals on these ropes. You can see more rope nurseries from the Seychelles. And the use of nets in the Red Sea, PVC trees in the Atlantic. This is in Florida from the Florida nurseries. These are called tree nurseries. And it's interesting to explore the relationship between silviculture and marine aquaculture, which I actually do in the book. All right. So in the midst of this third global bleaching event, two women coral scientists have come together and have developed a project to breed captive corals who have survived in the bleaching events and who are more tolerant, supposedly, to climate change. So these are the women, Professor Ruth Gates, who just died a couple of years ago, just as my book came out, who was a great resource for me, and I treasure our communications. And Madeleine van Oppen from the Ames Institute in Australia. And they were planning to kind of foster a super coral, the super coral of the future. So the process of propagating and introducing these supercorals into strategic locations on the reef, these women say, would accelerate natural processes that are perhaps happening too slowly to deal with the massive impact of human-induced climate change. They call this process assisted evolution, and it is performed in two stages. First, selectively breeding those more sturdy genotypes of those corals, like I said, that who survived the bleaching events, but then also conditioning them to be even more resilient. So Ruth Gates described to me, we are running, and I'm quoting, we are running our corals on environmental treadmills with the idea that what doesn't kill you makes you stronger. So here are some of the images from the experiments that Ruth Gates and Madeleine van Oppen have conducted in both Hawaii and in Australia to basically For example, this experiment in Australia looks into corals in 3 different climate scenarios: current, mid-century, and the end of the century, as projected by the IPCC, to see how they function under these stressors. We have to be realistic about where we are, Gates told me. And I'm quoting, "For the most part, coral reefs are almost all declining. That means it's not sufficient to step back and wait. People tell me that nature might do it by itself. It might, but it doesn't seem to be, not quickly enough." So I described the oscillation between despair and hope, and I'd like to take us to what I feel. Oh, here's some more images from the Hawaii aspect of this experiment, this time experimenting with pH. And these are coral nubbins that are in different pH levels in the ocean. So I'd like to move from this oscillation modality to propose a concept. The concept is correlation. And I guess what I'd like to offer is that corals, as these organisms, they actually can show us a way beyond this binary and this oscillation. They this concept that I'd like to offer expresses the connectivity between individuals and collectives, between social, physical, between nature and culture, between animals and humans. And it comes to challenge the bifurcated outlook on the world that oscillates, like I said, between hope and despair, between preservation and restoration, and to offer a hybrid point of view and interconnectivity in their place. So corals are great to think about a different way of thinking because they confuse and they destabilize our categories. They are animals, but they also photosynthesize, right? They are a cross between animals, plants, rocks. You know, some people used to think of them historically as rocks, these reef building corals, and they're also ecosystems. They make massive stony structures that can be seen from outer space, but they're also tiny and some might say fragile creatures. They're sessile, but yet they travel long distances in their larval stage, and each has a mysterious relationship with a particular strain of algae. And finally, unlike most animals known to scientists, corals don't seem to age, at least when humans don't impact them. And given the right conditions, let's put it this way, corals can seem to be able to live forever. And so it's not surprising, perhaps, that the scientists who study corals also promote a more rhizomatic outlook on the world, highlighting ways of thinking that are non-hierarchical, that are multiple, and that are less arborescent. So in the sense of they don't work through dualistic categories and binary choices. So less of this Darwinian way of thinking toward more of a rhizomatic way of thinking. And actually coral scientists, some of them call it reticulate evolution. And Darwin himself interestingly acknowledged in his notebook, the tree of life should perhaps be called the coral of life. This is kind of to indicate that maybe even Darwin himself was kind of less Darwinian than he was later interpreted to be. So this is what happens when we think about these tropical, with these tropical corals, right? And here's some beautiful images, and I love to show these images, right? From close up of these tropical corals. So this is what happens when we start thinking with them and with their kind of multiple ways of living. And if you add to this also the existence of soft corals, which have a different number of tentacles. The octocorals, for example, have 8 tentacles. And here's an octocoral for you guys to see. And so they have different relationship to a different skeletal composition, but also different symbiotic relationships. Oops, I didn't want to get here yet. And you get a mind-blowing diversity that raises a set of questions that are also relevant to the management of conservation. So scientists have noticed that octocorals, for example, don't bleach as much as stony coral relatives, and they're asking what that means for the rapidly transforming ecosystems in the oceans, and what do the corals of the Anthropocene look like now that there are more and more octocorals who are surviving these heating waves. One more correlation to consider is the deep sea corals. And so as coral scientists have discovered pretty recently, more than half of coral species are actually not shallow corals, but live in the deep and cold ocean. And unlike those corals who live on the surface, those deep sea corals do not photosynthesize, and thus they probably do not bleach. But they face other threats, such as bottom trawling, deep sea mining, and ocean acidification, which I think we will talk about in the next presentation. But because of their invisibility to our eyes and the relative weakness of the legal structures that pertain to most of their ecosystems, which are under the structure of the areas beyond national jurisdiction of BNJ. Because of these weakened legal structure, they are less protected than their shallow kins. And so I'd like to kind of connect to what Jonathan said and propose that there is a need to establish deeper correlations in managing corals. What I mean is there's a need to recognize that the materiality of the corals is complex, and so the methods of governing corals need to also be a little bit more complex and less anthropocentric in our biases, demanding innovative approaches in our government structures, in our legalities, if their decline is to matter for how we manage this planet in the future. Because coral life is very much dependent on our priorities, on our choices, and on our legal structures. And so when we prefer certain species over others, and so our legal and administrative structures are set in a certain way of thinking about classifying, regulating, and governing life, then we actually create these lives and impact these lives effectively. So if we are truly to protect corals, then changes to the current regulatory regimes must be considered that take their complex nature into account. The task of rethinking coral law and making it more correlated is especially urgent at this time when coral ecosystems are disappearing at a dizzying pace. Corals can and should serve as our guides on this journey toward a much needed alliance between law and science. So let me end by saying that corals are not only canaries in the coal mine. They're not only visible manifestations of the radical changes that we are causing to our ecosystems and to our cultures, human cultures as well. They're also bellwethers. They are sounding the way through this mess toward a more mutualistic way of being in the world that resists classification, that resists linearity, and that resists binary thinking. And while their acute bleaching around the planet provides a sign that something has gone terribly wrong on a global and fundamental scale, the multiple and varied ways that scientists, managers, and the corals themselves have been dealing with bleaching and the science law alliances that have evolved to protect corals remind us that the situated, the local, and the relational still make a difference for our correlated future on this planet. Thank you.
Thank you, Irus. That was a fascinating paper. Yeah, really interesting. And I've got loads of questions myself to ask about the regulatory structures that we might have in place, but we'll get to that in a bit. Okay, so our next panelist is Shaina Sadai. Shaina is a PhD candidate at the Climate System Research Center at the University of Massachusetts, Amherst, and holds an MS in Applied Mathematics. Her research uses global climate models and regional ice models to understand how changes in the Antarctic ice sheet could impact future global climate conditions as anthropogenic greenhouse gas emissions increase. She is interested in how these physical changes interface with social, political, and economic structures to create climate justice implications for humans and non-human animals alike. Shaina is going to talk to us about climatic change and multi-species justice. Shaina, the floor is yours.
Thank you so much. Let me get this screen share going. As Dr. Pepper just said, I work on physical Earth system modeling, projecting out changes in the climate system forward over the next 250 years. And I do that using a combination of ice sheet modeling and global climate modeling. And I'm very interested in how these changes will impact multi-species justice as well, though I am not a biological scientist, I'm a physical scientist. So I'm going to be talking about physical changes in oceanography and the cryosphere and how they could impact non-human populations. So just to bring us back to some of the things that Jonathan was going over earlier, which is that we are in the middle of a climate crisis and emissions have been increasing steadily over the past couple hundred years, and they show no sign of peaking or declining, despite the fact that there is international agreement to try to rein in the global mean surface temperature rise by the end of this century. So we have the Paris Agreement, and it is discussed in terms of limiting the temperature rise to less than 2 degrees Celsius and preferably less than 1.5 degrees Celsius. But as it has thus far led to no emissions reductions, we are currently on a path to a warming of at least 3 degrees Celsius by the end of this century. However, discussing simply global mean surface temperature neglects all the other impacts from climate change that are not just temperature based, and also neglects the consideration of regional variations instead of just global means. And so simultaneous to the climate crisis and very much entangled with it, we have a global biodiversity crisis. And that is driven in large part by changes in land use, climate change, direct hunting and poaching, pollution, and the so-called invasive species. And as you can see from this chart from the IPBES biological diversity report released a few years ago, species extinction rates are increasing over time. And the start of many of these things are connected to the same things that led to the climate crisis, which is colonization, racism, other forms of exploitation and injustice. And so I also want to note that biodiversity is one lens in which we speak about non-human animals, but I'm also interested in the impacts to non-humans on a community-based level and on an individual level as well, because their individual experiences of the climate crisis will vary greatly, and what a specific individual experiences will vary over time by geographic region and by personal experience. And so turning to our oceans, much of our Earth is covered in ocean, and the oceans are extremely important for transporting heat and nutrients around the planet. They are an important part of the global carbon cycle, and they're also home to an absolutely enormous variety of marine dwelling beings. But they are currently undergoing very rapid changes. And this chart sort of summarizes what some of these are, with acidification, increase in heat content, deoxygenation of the ocean, so the loss of oxygen, and the melting of the cryosphere. So all of the ice-based surfaces of the planet, including the ice sheets, sea ice, glaciers, all of these are declining already and projected to decline more in the future. And so let me, whoops, sorry, it jumped a little bit for a second there. So as Jonathan pointed out earlier, the oceans are taking up more than 90% of the excess heat that is accumulated in the Earth system as a result of anthropogenic greenhouse gas emissions over the last few hundred years. That is a substantial amount of the heat content, and it means that we are not experiencing as high of a temperature rise in our air temperatures, but a substantial increase in the ocean temperatures, though of course the oceans are rather enormous and have a very large heat capacity. So how that actually plays out spatially is different in different places. And some of the results of this rising temperature are changes in ocean currents, increases in stratification, which reduces the mixture of heat and nutrients throughout the water column, which is very important to non-human communities. Also sea level rise, increases in storm severity, and impacts of warming waters melting the ice sheets. So this increase in the heat content of the ocean is projected to increase over this century, irregardless of what emission pathways are. It will continue to climb, but how much it continues to increase by depends on the trajectory of our emissions. So you can see here in red is a high emission scenario, in blue is a low emission scenario, and then the green is sort of the observational data set that's putting us on that path. And so you can see that there is a substantial difference. We would far prefer a lower amount of heat increase than a higher amount because it makes it more likely for species to be able to adapt. And this heat increase is especially pronounced in the surface layers of the ocean. So with that increase in sea surface temperature, it inhibits the mixing of the ocean, the vertical mixing of the ocean, which is important for that movement of nutrients that's necessary for marine ecosystems. Increases in temperature, the surface temperature of the ocean are also what is driving the increase in frequency and severity of storms. And so one result of that, a friend of mine, Dr. Vodman, just posted on Instagram the other day. She was walking along the beach after a storm, and all of the non-human beings that were tossed onto the shore by those storms. So I think this is another impact that we don't often think about, but all of those increasing storms, as well as alongside inundating human communities, they are violently displacing non-human individuals and taking them from the water and often depositing them on the land. So along with this increase in heat, we have a growing phenomenon of marine heat waves. And I think we're all familiar with what a heat wave is like when we experience it in the air temperatures. But the same thing happens in the oceans as well. There are ocean heat waves, and these are defined in various different ways, but it's usually as if a sea surface temperature is exceeding like the 99th percentile of how hot it generally gets in that region, and especially if it's exceeding that high temperature range for a period of consecutive days. And, you know, maybe some of us have the option of going into an air-conditioned building or something like that, but it's very hard to escape these sorts of things in the ocean. And these are projected to double in frequency, to become longer lasting, to become more intense, and to cover a larger area over time. And so this is sort of a difference of how severe and frequent heat waves would be under a low emission scenario versus under a higher emission scenario. And you can imagine the impacts that this has on beings that are experiencing it. So these marine heat waves have already caused mass devastation and suffering to non-human communities. They contribute to wiping out the corals, as we just heard of, the kelp forests as well. And they can have cascading effects on entire ecosystems. So one particular instance where there was an ongoing marine heat wave in the Pacific from the years 2013 to 2015, it ended up causing an increase in the metabolism of plankton and fish in that region. They were not able to get enough food. They were suffering from the high heat conditions, and there was a die-off of plankton and of smaller fish species, which then cascaded up the food chain as it led to devastation within the communities of whales, sea lions, and puffins, and especially the communities of a certain seabird called emir, which it was projected that at least 500,000 individual MERS died during that period, and possibly up to 1 million as a result of starving to death, because the lower levels of the food chain had started a population collapse, and that cascaded up the food chain. Another impact of the changing oceans is acidification, as we just heard about, and this is projected to increase over time as well. You can see again the low emission scenario projections are in blue going out to the end of the century, and the high emission scenarios are in red. So under a low emission scenario, this acidification might plateau at some point, but under a high emission scenario, it just continues to increase. And so this is occurring because of CO2 emissions, largely from fossil fuel burning, and the oceans are taking up 20 to 30% of that increased CO2, causing the acidification. This then has impacts on organisms because the seawater itself becomes corrosive to shells, especially beings that form calcium carbonate shells or use calcium carbonate in their skeletons. And so this is causing a thinning of shells, which you can see here in these images. These are foraminifera, and in the top, these are modern foraminifera. And in the bottom, these are ones from the 1800s, which were in a museum collection. And you can see just the amount of thinning that's occurring in these shells. This is another projection of images of shells from the Arctic. And I think that this is, it impacts crabs as well. And I think of this sort of as also an issue of disability justice within non-human communities, because this acidification is having impacts that is causing disability to non-human animals that is then impacting their ability to live safely. It also has impacts on non-shell forming species. And so these can include a decline in cognitive functioning, impacts to their sensory awareness, to vision, to the ability to process sound, the ability to sense magnetic fields. This is an anemone fish, and studies have shown that their increasing exposure to acidification can cause cognitive limitations that can make it more difficult for them to find suitable living habitats. I also want to note that some of this research is done through animal testing, and that some of the ways that scientists are learning about the acidification impacts on non-humans is by purposefully subjecting them to these increased CO2 conditions in a laboratory environment under the justification of needing to know what could happen to these species in the wild under sea level rise. So I think that that is another avenue that we need to have discussions about. I personally am uncomfortable with it, but I do want to point that out as well, that changing climate is also impacting animals in laboratories in different ways. So another impact is the loss of oxygen in the oceans. And so we have this decrease in oxygen. Warm water is actually able to hold less oxygen. And as I said in the beginning, warm water, especially in the upper surface layers of the ocean, is causing decreased vertical motion, inhibiting the mixture of nutrients and oxygen throughout the water column. This decrease in oxygen and the warming can increase oxygen demand due to an increasing metabolic rate in some animals, especially in large animals. It can make it very, very difficult for them to get adequate oxygen. And two of those species that are particularly affected are the swordfish here and this tuna. So that's another thing that we need to consider. And this is also projected to increase over time. So this loss of oxygen, and especially anoxic zones where there's just oxygen minimum regions, are increasing. And so this is, again, under low emission scenario where it declines, but then it plateaus. But under a high emission scenario, this loss of oxygen in the ocean is just increasing substantially. And so I'm going to switch for the rest of the talk, or for the next section at least, to the cryosphere. And I just wanted to orient us to some cryosphere terminology for folks who are not familiar with it. Sea ice, when I refer to sea ice that is forming on the top of the water. It's sort of free-floating ice. There's the ice sheet, which is grounded on bedrock. So the ice sheets exist in Greenland and in Antarctica, and I think much more about Antarctica than I do about Greenland. So yeah, we'll orient questions that way. And ice sheets are stabilized on the bedrock at a position called the grounding line. And then in front of the grounding line, especially in the Antarctic ice sheet, are these ice shelves. And so those ice shelves are floating extensions of the ice sheet that are coming out over the ocean. And so this is that area where I was saying that increase in heat buildup in the oceans is getting in under the ice shelves in the Antarctic region and melting away at these from below, which then causes this to retreat. It can cause the grounding line to move back, and that can cause destabilization. So the Antarctic ice sheet is particularly vulnerable to a process called marine ice sheet instability, and also likely a process called marine ice cliff instability. And you may think from looking at pictures of Antarctica from above, it's a giant block of ice. You might think that underneath all that ice is sort of a continent in the shape of the ice sheet, but it's actually not. Antarctica is more of an archipelago underneath the ice sheet. It's a series of islands. And so thinking about Antarctica, this is the west part of Antarctica. So this is considered the West Antarctic ice sheet, and this is considered the East Antarctic ice sheet. So the East Antarctic ice sheet is more stable because the bedrock underneath it is above sea level. So that's all those places in green. But these places in the lighter blues, these are places where the ice sheet is actually grounded on bedrock that lies below sea level. So if the ice sheet begins to retreat back into some of these areas, it can cause a catastrophic instability where there's nothing that's really available to buttress the ice sheet after it moves past a certain point. And so this is showing regions where the ice sheet is beginning to move rapidly. The places in red is where this motion is accelerating. And so there's particular vulnerability in the Ronne ice shelf, the Ross ice shelf, and in Pine Island and Thwaites Glacier in the West Antarctic ice sheet. And these regions are all they lock up a lot of sea level rise. And so this destabilization is important for the Arctic ecosystem, for the physical oceanography of the region, and for sea levels around the world. And I wanted to point to just give you a specific instance of how changes in the Antarctic ice sheet can impact particular communities. And so this is an emperor penguin family over here. And there was a large colony, the Haley Bay colony. It was the second largest emperor penguin colony in the world. And they rely on the sea ice for their breeding habitat. And so this particular colony hosted 14 to 25,000 breeding pairs. And what they need for a successful breeding season is for the ice to stay stable from April when they arrive to December when the chicks have fledged and grown their adult feathers that are suitable for swimming. And so if the ice does not stay stable for that period of time, then it can cause colony collapse. And so in this region, what happened from 2016 to 2018 was that there was a lot of storms that blew the sea ice away from this region, and it made this area particularly unsuitable, and this colony ended up fully collapsing. And so there wasn't necessarily a direct climate link in this particular instance. This was more research that was being used to show what could happen as changes in the ice sheet and the sea ice surrounding it change in the future. And so what happened in this particular instance was there ended up being an increase of penguins at another location about 50 kilometers away. And it seems that they were doing their own adaptation. They were moving from a less suitable site to a more suitable site. And so this is some images from my own research. What we have on the left is the subsurface temperatures in the ocean. So at about 400 meters water depth underneath those ice shelves. And you can see that it's steadily increasing over time going through the next couple centuries. And what we have on the right here is the buildup of sea ice thickness around the continental margin, which may seem counterintuitive because it is a high emission scenario that I'm showing in both images. So our current modeling projections for the future for how the ice sheet destabilization might impact global climate, our future modeling projections don't usually include a realistic amount of melt coming off the Antarctic ice sheet. So what my research seeks to do is use ice sheet models to predict the amount of melt that could be coming off, then use that amount of melt to drive a global climate model to see how that amount of meltwater could impact global climate. And all of these things are a result of that increasing meltwater. So as the ice sheet starts to destabilize, we have all this fresh water going into the salty ocean around the continental margin. That is causing that increase of stratification that I told you about earlier, which decreases the vertical mixing in the ocean, trapping that heat at depth. But this is particularly important for a Southern Ocean ecosystem where many of the species in this region are cold adapted. And so if that temperature gets too hot and gets out of the range that they are adapted for, it can cause mass die-offs. And it's thought that somewhere around 79% of Southern Ocean species are going to be at risk of losing suitable habitat over the coming century. I also want to turn to a different thing. So I do future modeling, but for some of the observational data that other scientists are using at the moment, we have very limited temperature and salinity sensors in a lot of the polar regions. So what people have turned to is to have animals collect data for them by attaching sensors. And this is being done with whales, with seals, and with sea turtles. And these are supposed to be minimally invasive, but I think there's a lot that we need to talk about with this idea. I think we need to consider agency, we need to consider consent, the amount of stress that maybe having these placed on them is doing. But I think we also need to talk about what does meaningful co-production of knowledge between species look like. So perhaps in getting this temperature and salinity data, the animals are certainly collecting the data in the regions that they are utilizing. And so this data would be the most useful to what they would need, but is it being used for their benefit? I just think that there's a deeper conversation that we need to have about what meaningful co-production of knowledge looks like between species. So I just wanted to bring this up as well. And then turn to sea level rise. And so this destabilization of the Antarctic ice sheet, the increase in heat content of the oceans that I talked about earlier, the melting of the Greenland ice sheet are the primary drivers of sea level rise, though there are lots and lots of other things that go into determining what sea level rise will be. Those are just the primaries. And so sea level rise is going to continue for centuries, even if all emissions stopped tomorrow, just because of thermal inertia within the climate system. And so the question remains, how much is it going to rise by? And so these are some projections from the IPCC Oceans and Cryosphere report showing that under low emissions, we have a steady rise, but not a substantial rise. Going out to the year 2300 here, the year 2100 is here with this little inset. And under high emissions, it rises substantially, and in large part due to a destabilization of the West Antarctic ice sheet and that increase in thermal heat storage in the oceans. And so sea level rise is also not spatially uniform. It varies geographically all over the planet. So the relative sea levels in different regions will be different based on the combination of factors and how they impact that specific region. And so adaptation methods also vary greatly. And in different regions, different adaptation measures are going to be turned to by the human population, and non-human populations will adapt as they see fit as well. The issue arises when human adaptation efforts impact non-human species and individuals in detrimental ways. And I want to point out that our moderator, Dr. Angie Pepper, wrote this article on adapting to climate change and what we owe other animals in terms of adaptation assistance. Jeff Sebo and I wrote this piece for Sentient Media a few months ago. The coasts are disappearing. We need to protect them for everyone, just basically pointing out that as we consider sea level rise adaptation strategies and adaptation to other climatic change effects, that we need to consider the spaces and as they're being used by everyone who lives there, non-humans and humans alike. So these are some pictures from Gary Appleson, who is a policy director at the Sea Turtle Conservancy. And so these are showing sea turtle nesting sites and sea walls. So the construction of sea walls protects human property, but it can also limit the ability for sea turtles to find adequate nesting sites. And some of these nesting sites that are placed in front of seawalls are vulnerable to being washed out to sea at high tides. You can see in this picture, a sea turtle had come up, was looking for a suitable site, did not find one, and made their way down the beach to try to find something a little bit better. So this is one consideration that we need from the policy side. And then I also want to point out that climate change is not happening in a vacuum. There are many other stressors that are occurring within non-human communities. This is a map of global fishing routes in the year 2016, with these brighter colors being more amount of fishing area hours per square kilometer. And so the impact of fishing is substantial over over the oceans in general, and is also a huge contributor to the pollution crisis via abandoned fishing gear, drift nets, gill nets, and the like. There's also the plastic crisis, which this poor baby sea turtle succumbed to too much plastic that they had found and thought to be food. So in addition to the stresses from climate change, there are also the stresses from these other activities. And so we need to consider multi-species justice. I always consider that climate justice should be multi-species. It's climate justice should apply to all beings living on this planet. And so I've covered that the oceans are heating up, they are storing an excess of carbon leading to acidification, they are deoxygenating, they are undergoing circulation changes and increased stratification, which is inhibiting nutrient availability and oxygen availability. They are also undergoing sea level rise, which is impacting the coastal communities. And when we think about climate justice, it's generally threefold, considering procedural justice, recognition justice, and distributive justice. So procedural means is there a reasonable representation within the decision-making process, especially in a policy landscape? And I don't think that non-humans currently have adequate procedural representation. Recognition justice, which is the right for an individual or a community or a species to continue to exist. And then distributive justice, which is talking about the spatial and temporal variation in the impacts of burdens and benefits of climate change. And there's very few benefits of climate change. But marine dwelling beings, I think that they need to be able to adapt as they see fit. And as Dr. Pepper pointed out, they might also need adaptation assistance in many cases. They need climate mitigation because, as you saw in all of the time series that I showed for the future projections this century and into the coming centuries, we need mitigation. We need the lower emissions pathways in order to decrease the detrimental effects of the climate crisis. And we need to decrease other compounding stressors like fisheries and pollution. So they need their needs considered in policy. We need to also consider these things such as data collection and co-production of knowledge, and to consider how animals are being used in the laboratories with the justification of needing to learn how their wild counterparts or their counterparts that were not taken from the wild are experiencing sea level rise. So I think there's a lot to consider here. And thank you so much for listening to my presentation. I'm going to stop the screen share now.
Great, thank you, Shaina. That was very thorough. I guess I have a question, so I'm going to kick it off. It seemed to me that in all of your talks, there is this kind of issue about the tension between saving and harming individuals and saving and harming species. So it came up for Jonathan. I mean, you mentioned assisted migration. So that might be something that we try to do to save the species, but in doing so, we're likely to harm many of the individuals who are moved. Irus, you mentioned the lionfish, right? So when people are trying to protect the corals, they might do so by harming other individual non-human animals. And Shaina, I think that the stuff that you talked about with regard to experimenting on animals in order to predict, right, the impacts of climate change is another case where you take individual animals, you expose them to harm in order to save species. So I was just wondering whether any of you have any like reflections on that kind of tension. Like, do you think that harming individual animals can be justified, right, in order to like preserve the species? Do you think that in fact individual animals have rights, right, that can't be transgressed in order to save species, and that species aren't the important thing, but the individuals are? So does anyone have any thoughts about that, or is that a bit too much at this time of the day?
I mean, that really goes back to the fundamental difference, philosophic, normative, between the animal rights approach. Maybe we'll toss the animal welfare people with it, and the ecological approach. And so it goes back, to debates in the 1980s about whether to take the American condors into captivity to save the species or not, into the whole debates about compassionate conservation, as Mark Bekoff calls it. And so I think it is a fundamental debate that is ongoing. Where what do we value? And I think it's an important debate, and it's important that it becomes transparent. What I find is that a lot of people, when they speak about conservation, they focus on the make-live aspect of conservation, and they don't like to speak so much about the let die or the make die. So I'm speaking specifically in Michel Foucault's terms of biopolitics, and maybe to add necropolitics here. I don't know how theoretical we want to get, but I do think that there are underlying value judgments and biases that go into our decisions, and every decision to save a species is necessary, or to make live a particular individual, not just, is also at the same time a decision about others for different reasons, a decision perhaps to let go of others. So I feel like it needs that kind of value judgment, and that kind of process needs to be a little bit more apparent and less hidden. And perhaps, as Shaina was kind of pointing out, we need also procedural justice in the process. So how do we create structures that enable more just representations and other voices to be heard? And I guess maybe I'll bring back the correlation aspect. And one of the other panelists was kind of asking me in a chat, so can we take the correlation thing and apply it to other than corals? And definitely yes, this is kind of what I was hoping, that by looking through, I think corals are just more visibly challenging our classifications and our categories. But in fact, if we just look carefully, each organism would do that, including ourselves. We are holobionts ourselves, like our idea of seeing ourselves as individuals. And that comes to your question as well, like individuals versus species. That, again, is another bifurcation that maybe thinking in a correlated way might allow us to think beyond, right? And here I might invite others to think with me about that aspect. So I'll stop here.
Yeah, I would sign on to all of that. I think I have a couple of thoughts. It's interesting, this debate, especially when it comes to climate. There's about 98% of the problems that we face, species and individual animals and people all have aligned interests. But I feel like we, especially in the academic space, sometimes can be pulled towards discussing where the conflicts happen, because we feel like that creates the interesting ethical question. And I would agree, in those few cases where they diverge, there needs to be transparency. I find the debate around compassionate conservation interesting, not only because this has been a long-standing feud, but that particular movement was from the conservation side, trying to interject animal welfare or humane ethics into conservation, and that people lost their minds. I mean, people published papers saying that this was going to be the death of conservation. And so this idea that if we move off single issue advocacy and do anything other than advance our little siloed interest, that if we move off that, it's the end of the world for you name it, whether it's human rights or animal rights or welfare or conservation. That's the part of this that we have to fight. The idea that if we recognize multiple interests that can come into conflict and talk about how we're going to reconcile them, that somehow that's a disastrous situation and takes our eye off the ball, that's a reality about doing anything effective. So I think it's a really interesting question, and one that needs to be totally reoriented in the ways that have already been discussed.
Great. Shaina, did you have anything to add or?
Yeah, I mean, I guess when I think about this idea of saving individuals versus saving species, and like sacrificing individuals to saving species, like I'm inherently uncomfortable with it because I do think that individual experiences matter. And I also wonder about sort of like the framing and the motivation behind like the benefits or a perceived harm, like if it's more about human ego at having let too many species die and like sort of losing track of like that a species is comprised of individuals. So I sort of wonder yeah, I mean, I'm inherently uncomfortable with the idea of sacrificing individuals for the good of the species. I think we need to address the underlying issues that are causing both species and individuals to be declining in the first place and get to the root.
Yeah, that seems right to me. Okay, so I'm going to move on to some of the questions that have come through. The first question is really about how, so we've kind of made this case that there are all of these animals that are being negatively impacted by anthropogenic climate change and that they need to be assisted, right, in responding or adapting to climate change. But there are so many animals. So you've all done a really good job of like kind of illustrating the size of the challenges that face us. But then the question becomes, how feasible is it to try to address this challenge, right? There are so many animals, right, in need of assistance that the economic costs of trying to save them all are going to be really vast. And this wasn't part of the question, but I've, had this question raised in discussion before. There are going to be lots of humans, as we've also mentioned, who are going to be negatively impacted by climate change. Shouldn't we start there first, right? Like, why you're thinking about all of the costs involved? We've got limited resources, so is it really practically feasible to be trying to save all of these wild animals from the negative effects of anthropogenic climate change?
So this question of economics comes up so much in discussions of climate mitigation. Like when is it cost effective to do climate mitigation? But it's like it has to be done to have a more just future for all of us. And really the costs of mitigation are much lower than the costs of dealing with continuing severity of detrimental effects. And so I think that like even placing the emphasis on money and on economics sort of takes away some of the spotlight on where I think it should maybe more appropriately lie, which is the impacts themselves and the vast suffering that climate change is bringing to both human and non-human populations. And I don't think there needs to be a dichotomy between helping humans and helping non-human animals. I think that the solutions are things that can be beneficial to everyone. And so I think a lot of like ecosystem restoration and a healthier environment for both humans and non-humans alike is something that I don't know if I can really like even put a price on it. But yeah, so the economic framing.
That answer was so good that I don't really, I try to think of something to add, but I really can't.
Okay. Okay, so there's a few questions for Irus here. So one question is whether you can just clarify what you meant by polarization. Another question is whether you can just say a little bit more about how far coral travel in the larval stage. So just start there, because those two questions are less long.
Yeah, so just to highlight, I'm not a coral biologist. I think there was another biological question there about, I can't remember. Oh, were there any geneticists involved in the process of this assisted evolution, and were there So just to read it, and I guess I'll try to combine these questions. As I understand it, the project was subjecting them to temperature change and other stressors, and to see which ones survive, and then cultivate those and repopulate the original areas with these. So there are multiple strains of this assisted evolution work, and I'm not, again, a coral biologist. However, I did study this for 7 years, and I would recommend looking at the book. There I really go into the details. However, it's been quite a few years, so the details are kind of lost on my aging brain. And so I guess I will just say, I will say briefly, yes, I think, Suzanne, you got it right. There is on the one hand, pulling out those corals who are more resilient. And so there's been quite a few studies on that front, finding these more resilient corals to pull out. But then to make the super corals, as Ruth Gates explained to me, there was an additional stage. So on the one hand, those already resilient ones, in an intergenerational kind of putting them on these, what they call treadmills, right? So like you said, exposing them to more stressors in a way, and conditioning them to become even more resilient, but then seeing whether they could create these, understand these epigenetic triggers. How can they actually travel transgenerational? So how can they move between the generations so that it's not only that particular coral, those particular genetic corals who are going to be impacted, but also the corals who are reproduced from there. And I will say that coral reproduction is a very complex. We have more than 2,500 known coral species. So, and some of them have within a particular colony female and male corals, and some of them have them in separate colonies. So the reproduction gets complicated. There is asexual reproduction, which is what most nurseries have been doing, fragmenting corals, so creating the same genotype again and again. But then recently there's been criticism in the conservation community that we are kind of creating these forests of the same genome, right? So how do we do coral sexual reproduction, not just asexual? And that was is still being kind of thought through. So it's not just breaking them off and fragmenting them and creating more of the same corals, but how do we actually create a different coral in terms of their genetics as well? And after that, coming to the larvae question, right? How after that do we allow the larvae to settle? Because that's another difficult stage. After the spawning and the coming together of the egg and the sperm, then they travel across the ocean. At the ocean level, and then they finally settle. They could travel a day or they could travel weeks, so it can take them pretty far. And I don't know in terms of kilometers, but that would be something interesting to look into, whether there were studies about that. But it could take them pretty far, you know, definitely further beyond the marine protected area or something like that. So that kind of, you know, comes to also be an interesting aspect about migration, the movement of species beyond their protected areas, to come back to what Jonathan was kind of saying about movement and migration. And so, yeah, these, I find the biology of corals to be mind-blowing. Like every time I think I get it, like there's more complexities. And a lot of these coral scientists who I've been speaking to, a lot of them are geneticists. And in fact, some of the debates within this community, there are certain tensions within this community that I documented in the book, and some of it is between geneticists and ecologists. And that, I think, also echoes the larger conservation scheme in other species conservation. So these tensions between the geneticists who tend to be willing to, or synthetic biologists who tend to be willing to intervene more, and it raises questions about how much will we intervene? Are we gonna intervene in what life is, in the genetics. Are we going to use CRISPR technology for gene editing? How far are we willing to go with this? Or are we limiting ourselves to just selective breeding and just putting them on, what Ruth and Madeline insisted with me is not genetic modification, but simply selective breeding like we've been doing for hundreds of years for plants and animals. So this just to say that coral biology is fascinating. And again, to come back to the fact that I think it highlights for us that ways of thinking and ways of governing have to take into, have to consider these different biological and reproductive modes. So when the Endangered Species Act that Jonathan mentioned looks into what is a species in order to protect them, corals don't necessarily nicely line up like that. Sometimes you can't really determine what a species is or what even an individual is. Angie, to come back to your question between saving individuals versus saving species, corals throw that all up in the air. What is an individual coral? Is it a polyp? Is it a colony? Is it the population? Is it the genotype? Is it the ramets? It's like, then I think if you just follow the materiality, you kind of, again, come to understanding the much more complex, fluid, and relational aspects here. And I think that will bring us to perhaps being a little bit more creative in our ways of adaptation and mitigation and handling these complex issues that we have at hand. I think that covers all of the questions. Oh, except for polarization. Should I try at that too, or should we let go and move on?
I think you could just briefly clarify.
Okay, so polarization, I didn't mean between the North and South Pole or something like that, but more of a theoretical concept of just shifting between extremes. That's kind of what I meant. And I see that a lot in different ways of thinking about nature that my work challenges, for example, between ex situ and in situ, between captive and wild, between nature and culture. And I feel like, again, these polarized or bifurcated or juxtaposed categories are sometimes prisons to more creative ways of thinking that I think this time requires. So rather than moving between these polar extremes, I suggest to work through them and perhaps beyond them. And that's kind of what the term called correlation was supposed to interject.
Thank you. So there are quite a few questions in the Q&A box around testing. So Shaina, this is one for you. So people are, rightfully concerned that experimenting on animals in order to predict what's going to happen to animals with regard to climate change in a way just reinforces, right, human dominance over other animals, and it's problematic for all of the harms that it's doing. So somebody asks, what alternatives are there to animal testing for predicting physiological and population changes in response to climate change? So have you got any sense of what the alternatives might be?
Yeah, I think the main alternative would be the non-invasive observation of animals just in their natural environment. We have such amazing capabilities to observe from a distance without interfering much in their day-to-day functioning. So I think observations in the wild would be far better than either taking an individual out of the wild or purposely breeding them in a lab to subject them to these conditions. And I also think that this, especially the research on maybe exposing them to high CO2 conditions and acidification to learn that they are cognitively impaired and have sensory impairments. I think that this is also, like I was saying with the shells, an issue of disability justice, of purposely disabling an animal for the purposes of just learning something about how they interact in a changing environment. So yeah, I think that non-invasive observation of them in situ, just in their natural environment, doing their thing, is far better than trying to do this in a lab. And in a lab, I mean, we've heard in earlier webinars in this same series about the numerous effects of that, and like what that data is even telling us about changing conditions in their natural landscape, like how it, there's just a lot there.
Great, thank you. Okay, so this is a question for like all panelists. Do you have any thoughts about how the COVID-19 crisis has affected the conservation of endangered species? And how does the perception of some species as vectors of disease and threats to human health affect conservation?
I think COVID is an excellent example for how interspecies justice and is urgent at this point. I think it makes acute connections between climate, between biodiversity, between human injustices, and highlights the need to conceive these at the same time, rather than creating little, silos where each one is considered separately. And I guess this is what some have tried to do in the context of what is called One Health, trying to look at the health of humans, the health of non-human animals, and the health of ecosystems. And one of the questions was about health of ecosystems, and to see them as interconnected. And in this particular context, one of my colleagues in the conference that we're organizing about One Health has actually just written me the abstract today about bats. He's a bat ecologist, and he feels like bats are seen as the bad guys now, right? But again, like Shaina was pointing out, there are structural injustices that have led to this proximity, perhaps, of these communities to humans, stressors that have made them more vulnerable to diseases, and then also the encroachment of humans into wildlife habitats have made the proximity much more likely. And so the jumping of these diseases from humans to non-humans, between non-humans, is much more likely. So whereas the emerging new diseases, 75% of these emerging new diseases are zoonotic diseases, at the same time, I want to say they impact non-human animals as well. They die too, right? It's and so the suffering is multi-species, and to understand and deal with the causes of this suffering, rather than just do like these fixes, like create an immunization or I think we need to look into our relationship with non-human animals and see what they are telling us that we're not really listening to, what they are screaming in our face, that there are these imbalances that have been created that are just so extreme. And COVID is an example of that. So we can no longer afford to not hear them and not hear the statement about what this imbalance causes in terms of the human, non-human interrelations.
Yeah, so the COVID pandemic has had a substantial impact on the scientific community. A lot of my friends are not able to go out into the field to do data collection right now. Like I have a friend who's a bat ecologist and observes bat colonies in the wild, and she hasn't been able to go get any new data this year. We're also losing a lot of marine data from the loss of like a lot of the sailing missions that go out to collect observational data or sediment cores or things of that nature. And so we're it's affecting the academic structures as a whole. So I think there's a lot of impacts there. And as Dr. Braverman was saying, like the COVID pandemic is a lot like these zoonotic diseases are driven by degradation of the environment and confinement of animals in small, often filthy and horrific conditions, like segmentation of different habitats, and it's all very interconnected. Like there's just so many justice issues at play here. But yeah, it's substantial, the range of the impacts that we're seeing right now and how this is going to cascade over the next few years, and then other zoonotic diseases in the future. I think if we don't handle the root of the issue now, or start putting into place ways of handling the root of the issue now, this is just going to keep happening over and over again.
Thank you. So that leads us to another question that is kind of coming up quite a lot in the box, which is about, I guess, what are we going to do, right? So this came up in many, like you all three gestured at, the idea that we need better governance, we need different laws, we need regulatory frameworks that actually work and protect other animals. So I just wonder whether anyone, maybe Jonathan, you could sort of say something about what kinds of things might we put in place to better protect animals' interests.
Yeah, I mean, the fundamental problem, and we're dealing with an area with a number of fundamental problems, but from a legal and regulatory standpoint, the climate crisis really points up a lot of existing structural inequalities in the system, but it also demonstrates all of the interests that lie outside the system's structure to even think about. So future generations of humans, animals, these are interests that don't fit within even a properly functioning interpretation. I mean, we have a system of laws and regulations that is applied and pursued in a way that's profoundly discriminatory towards humans, but there's also existing humans, but there's also these interests that lie even outside of that system. So I think figuring out a way to put those back into the framework and understanding the interrelated impacts and regulating in a way that treats like things, like one of the things in my presentation when I get down to some of the causal factors with regard to climate and animals is, of course, things like animal agriculture that, as we've just heard, have a connection with COVID and things of that nature. But we don't treat these systems the way we treat other industries. And so not only do we have a number of interests that are structurally outside the legal regulatory system, whether it's future generations, animals, but then we have a number of major actors that are just operating outside any sense of regulation or restraint. And even in those countries that are more serious about climate emissions, they're primarily focused on energy emissions rather than agricultural emissions, which have just been an area no one's willing to look for various reasons. So I think, it's a tall order, but we first have to have a conversation about what are all the interests our legal system should be considering. And then we have to build legal structures that treat stressors and impacts and transgressors of those interests in an equal way and not based on politics and who's in and who's out. And this is an incredibly tall order, especially in the climate space. It is no exaggeration to say that everything that we've done from a legal regulatory standpoint globally on climate is not working. This is a great time to think about new solutions. And maybe if we can make these connections, the One Health concept is something we chose for our speaker series this year in the Yale program, because I'm reluctant to talk about benefits or a silver lining of having a pandemic, but it has opened a conversation about the interconnectedness of human health, planetary health, and animal health. And that conversation needs to happen ethically, it needs to happen scientifically. And then the big, lagging indicator is action on the legal front. So we have to get the ethics and science organized, and then hopefully we can move that into the legal realm.
Shaina, did you want to add anything about the kinds of structures or policies you think ought to be implemented?
Yeah, I think to get policies implemented and to get people to really think about these things, we need to sort of reconceptualize how we're viewing non-human animals, which I know is just like a huge ask, but it's where we need to get to be able to take their needs seriously. And I think this, especially the issue Jonathan just brought up about intergenerational justice and like thinking long term, is something that humans are inherently not particularly good at. And this idea of like what we're doing right now, and really for the climate crisis, what happens over this next decade is really going to chart the course of how it's going to play out over the next couple centuries. And that's a big thing to wrap our heads around, like the fact that if we don't decrease emissions by more than 50% before the year 2030, we will absolutely not meet the goals of the Paris Agreement, however fraught I find the Paris Agreement to be. But I think that we need to start taking this sort of long-term look and to find ways of having that be important to people, having intergenerational justice be important, having multi-species justice be important. And we need to bring up that conversation a lot more in all of the spaces that we're in, however uncomfortable that may be. I've been trying to bring this up more and more in my own academic spaces, trying to get the question of animals on the table, trying to get the question of non-human justice on the table, and receiving just tons of pushback. But it has to be out there. It has to be spoken about before we can actually start to handle it. So I think normalizing these types of conversations can go a long way towards getting action on them.
Yeah, good. So I guess the one question that is in the box, actually, Shaina, that kind of relates to this is about the co-production of knowledge, right? So I take it that like something that's going to be really important to moving towards a more just world is like letting animals in, right? Letting other animals kind of inform us through their agency, right? And paying attention to like what they do. So could you say a little bit more about exactly how you're kind of envisaging the co-production of knowledge?
Yeah, so co-production of knowledge is a term that sort of like entered the scientific discourse through various forms of knowledge production between different groups of humans, and especially between indigenous scientists and scientists trained in more like Western European ways, and having this co-production of knowledge within different systems of utilizing science. So that's where the term of co-production of knowledge comes from. And then I'm sort of thinking about extending it towards co-production of knowledge between different species. I think this really needs to draw on work, and I'm just going to reference you here, Dr. Pepper, of working on ideas of how we can meaningfully determine consent when there are interspecies language barriers, and also the work of Ava working on how animals act with political agency. Like there are ways that we can observe animals and tell if they consent or dissent to something that's happening around them. And so I think that having really robustly looking at this question of consent and communication between species is going to form the basis of that, because how can you tell if a knowledge production is just if you have no idea what the other individuals involved in the process really is? But I think that there are avenues where it could be good to try to sort this out, to sort out co-production of knowledge between species, because if non-humans are driving some of the research questions and the data collection, like if we're really trying to put their interests and what they're concerned about first, and we can sort of guess at how that happens in different ways. Like we could maybe speculate that perhaps penguins are concerned about what changing sea ice concentrations in a given area will be, or that a certain fish is concerned with when the temperature threshold will exceed a comfortable range for them. And so we can sort of think about like, what would they be interested in? How can they get that knowledge? And I also think that non-human animals themselves operate by doing science. Like I do think that non-humans have their own versions of science. I think that they are always collecting and processing data in ways that are different and unique from humans through their utilization of like magnetic fields, and they can tell changes in temperature and salinity in different water regions of the ocean. So I think that non-humans themselves are already doing science, just maybe not in the way that we often define it. And so I think that there's a lot of avenues there if we can think about this idea of consent and what data they are collecting or would want to collect, and how they would want it utilized for their benefit. So yeah, that's some of my thoughts on that.
Great, that was a really comprehensive answer. So I want to bring it back down now to individual animals again. So we've been all the way to the top where we've been looking or considering governance structures. and frameworks for moving forward. But Marina asks about invasive species. So how do we distinguish between so-called invasive species and species that are adapting to new habitats in a warming world, and what we owe to those individual animals versus the changes that they're making to native ecosystems?
So I can speak from this from a legal standpoint. I've done a lot of work at the intersection between animal welfare and environmentalism, invasive species, exotic species. I think one of the first things we have to do is get our terms very clear about this. I think the whole concept of exotic or invasive species is based on the idea of a static system environmentally when it's changing. It's always been changing. It's always been a very problematic concept. But with climate change, I think long-standing concepts like exotic and invasive are becoming less useful. I think particularly exotic, the idea about where a species belongs at a static set point in time. We actually had a really somewhat comical situation under the Migratory Bird Treaty Act when Congress, the United States, decided it was going to only protect native species under that act. And they went round and round about how they were going to define that. And ultimately they decided, well, any bird species that was naturally present in the United States in 1918, which was the year that the statute was passed. And that was their definition of native, and everything else is non-native. And I like that story because it shows us how arbitrary some of these distinctions can be in a dynamic environment. So I think we have to think more about damaging species, what they're actually doing within the environment scientifically, rather than these sort of gross labels like exotic, non-native, invasive. And I think all those things are going to be challenged, and there's going to be really tough decisions to make about either allowing or assisting or forcibly moving one species to an environment where it hasn't previously existed. And if that environment is evolving into something that species needs, what about the species that are still desperately clinging to that changing environment, trying to keep from going extinct? And then on top of that, you have the whole issue of individual animals versus species or populations that has to be grappled with ethically. And then if you can get through all that, you have to get to the issue about resource use on human relocation, which we're not doing well at all right now, versus animal relocation. So it's a lot. It requires completely new thinking, and it requires us to be willing to challenge a lot of longstanding conceptions about what we do and don't do and why we do it.
Thank you. Irus, did you have anything that you wanted to add to this? Because you did mention the so-called invasive species.
Yeah, again, this has been an ongoing debate in the scientific community as well. And I will add, however, although I agree with Jonathan that there is an aspect of arbitrariness, but I think that that aspect is kind of inherent to any category or any classification, which is very a natural way that law proceeds, right? And even human thinking, if we want to take it further, right? We need categories. So why 18? Why not 18 and a day for, you know, for whatever, for voting, for this? So of course, every category, again, goes back to our binary ways of thinking and to try and challenge those. But I will add this kind of ecological perception that biodiversity is really important. And the example, for example, from bird species in Palestine, Israel, which I'm looking into, is the massive decline of 95%, say, of raptor species in the last few decades. Whereas there is an acceleration of 3 species, Myna being one of them, in 843% in the last 15 years. And so these species are kind of pushing other species away. Now, do we prefer one or the other? This is, again, comes back to the question of biopolitics. Why do we prefer one over the other? But there is also this underlying question of the preference of ecologists towards diversity and this idea that it might not be good to have one species take over. And so I think that aspect needs to be taken seriously when we consider how we balance out these different values. And I guess I agree that that we need to challenge these concepts, but at the same time, I think we need to bring in the different experts in order to do that. And that comes back to the issue of co-production. I'm trying to think about, I mean, I used it for correlation as well, this I guess, the co-production. Well, co-production, this term that Sheila Jessenhoff coined in her work on science and law, and showing that science and law are actually actively co-produce each other. And I guess I wanted to come back to that, because what I feel, and this is the importance of One Health as well, what I feel is going on is that a lot of experts sit in their own silos, and it's really important at this time to try and bring those silos together. So, i.e. to on the one hand respect the expertise, not to say that it doesn't have a place, but to also translate it across in a transdisciplinary manner, so that to inform different disciplines on what is going on, and therefore think about things a little bit differently. So this is kind of, I just wanted to add that to the issue of co-production, and the importance of having different experts sit together and actually speak across the board, and that includes ecologists and animal rights people. And I know Jonathan has been doing a lot of that, right? Like, we need to learn from each other's struggles and from each other's expertise at this time to move things forward. So I wanted to tap into that, and I guess that's all I have to say right now.
I also want to note just that this idea of the so-called invasive species is also like it's a very Western concept. I've read some works by various indigenous scholars who don't utilize the concept of invasive species and more think that any species that's in a given region is there for a particular reason, and so it's just approached totally differently as a concept in different cultures. And I also want to go off what Jonathan was saying about like what does the idea of invasion even mean under a transient system that is not static, is not in any equilibrium. And I think there's different considerations when individual animals or species are moving as a result of a changing climate, and when species are being introduced by means of human actions and then causing detrimental effects to a local ecosystem. And like, I think there's just like different considerations under both of those circumstances. So I just wanted to point that out as well.
Great. So I think we'll just have one last question and then we'll finish up. So
just to maybe say about Shaina's last comment, I guess I just kind of, this distinction between human-made and so-called natural changes, I find goes back again to the binaries that I wanted to question. I feel like it's really problematic. It's a rabbit hole because when you dig enough, then it's all anthropogenic or it's all natural, or what does that mean at this point, right? And I guess that goes back to another distinction that you were utilizing before between lab and wild animals, and this preference that you have inherent preference toward doing work in the wild. And I guess I would want to question that as well. In certain instances, the wild is not so wild anymore. And some captive environments are safer for non-human animals. And in fact, reintroducing them perhaps could be detrimental to their lives. And so these distinctions are exactly what we want to challenge in thinking and maybe break down a little bit. What does that mean at this point? Not to take any distinction in its rigidity and it's in its polarized state, but to look into the details of it. So I would question that distinction, that inherent, like, okay, in captivity bad, in the wild or in situ good, or the same goes to the human-induced and the so-called natural changes, which I find, you know, if you dig a little deeper, you go into these structural injustices that you were speaking about, Shaina, beforehand. So I think just to push you on that front a little bit, if that's okay.
Yeah, that's fine. I was mostly referring, when I was talking about like animals being used in the lab for the particularly acidification research, I was talking about like sort of the removal of their consent and agency at taking them out of a place where they were non-consensually and putting them into another environment as being the problematic aspect of that. Like,
Yeah.
They don't have a choice in being removed from their environments and placed in this setting where they're then being subjected to conditions that are known to cause harm.
But they also did not have a choice in being subjected into the acidified oceans or into the, the heating. I mean, and that goes back to these legal ways of thinking. Even consent is a very problematic anthropocentric term. Like, we are imposing this platform of consent, which is a contractual legal structure, onto ways of thinking that they might not be relevant for. Like, does a snail need to consent? Like, and does it matter what animal it is for this process? So I guess just to kind of, and what is justice in this context as well? I kind of feel like we need to break down that question as well. What does that mean? Is non-human justice the same as human justice, or human justice is the same across the board? I don't mean to explode everything, right? I'm not saying that everything is possible, but just to underline the anthropogenic thinking that sometimes goes behind these terminologies that we're using.
Jonathan, you wanted to say something?
Well, just briefly, yeah, I think one of the interesting things when I hear discussion about, well, are we responsible for those animals that we put there, or did they go there themselves, or what is the nature of consent, or all these other things in these spaces, I feel like we're dancing around this deeply uncomfortable realization that whether we like it or not, we're going to decide what animals survive on this planet and what animals don't. And, even if we decide to do nothing, that itself will decide a lot about what happens. And, as arrogant as humans are, I still think most of us are fairly uncomfortable with making these choices. And so we're looking at different distinctions, whether it's the conservation ethic and species level being the driving force, or whether we're coming at it from the animal welfare space and thinking about individual animals. All these different distinctions we might draw ethically are all little tools that we're grasping at to try to cope with this huge, terrifying realization that somehow we're going to have to make all kinds of choices about who lives and who dies on a grand level. And I don't think even the most arrogant among us is comfortable making those decisions.
No, I don't think they are.
But we're making them, that's the thing. And that's where
Right.
the transparency needs to come in. We are already, and we have been making them, but maybe not so much in a way that includes public participation and who is included. And that goes back to the question of procedural justice.
Okay, so I think we have time for one last question, so I will ask it. So somebody kind of commented in the box that, all of this can make you just feel despair, right? That it's frustrating as individuals because it's really difficult to see what you can do. And they suggested that, there are things. You could stop eating animals, you can reduce your plastic use, you can stop using fossil fuels, all of these kinds of things to reduce your impact on the earth and to try to mitigate climate change. But I was just wondering whether any of you think that there are other things that we ought to be doing that are more political, right? So things that we ought to be doing to kind of raise awareness about these issues that, everybody as an individual should be doing. So does anybody have any kind of suggestions?
I think that community involvement and local politics play a big role here. I think paying close attention to the things that are happening in your community at a policy level and with local organizing around social justice, environmental justice, I think that's really important. We all know our own home communities the best, and so that's a good way for us to get plugged in and start to work on some of these structural issues where we're at. So I think, yeah, paying close attention to community politics and community organizing is a really good place to get involved.
And I totally agree with that. And I will just add that one of the things I think that I see, I've worked in the environmental space, I've worked in the animal space and other spaces, and what I see over and over again is deep level of frustration. Why don't people care about my issue, whatever angle I happen to be coming about this? And then you ask people, well, what do you do to support other struggles for justice? And the answer is nothing or very little. And I think if we want issues like animal welfare, climate justice, these other things to resonate the way other social justice issues do, then if that is our issue, we have to show up for related social justice issues that stem from the same structural problematic oppression. And when we do that and we show up for other causes, we will create reciprocity that will advance issues that we think are neglected. So I think understanding the interconnection and acting on that in a multi-justice sort of framework is one of the most important things that people can do in order to, if you're worried about climate or worried about animals, show up for the related issues and start building those connections.
Yeah, I strongly agree with that. I think that's a lot of what I was thinking when I was talking about community organizing, is like, how are we working against colonization? How are we working against racism? How are we working against sexism, queerphobia, transphobia? Like, all of these issues are so deeply interrelated. And so that's really, like, effort needs to be happening there, whatever else we're doing, that none of that can wait.
And on that hopeful note, I will draw the session to a close. I'd just like to thank all three of the panelists for taking the time to speak with us and to answer the questions. At this point, I'm going to hand over to Kat, who is going to give us the details for the next session. Okay.
Thank you so much. I have to say it was an inspirational panel. Thank you to all the speakers and the moderator. And I thank you in the name of Eva Meyer and Charlotte Blattner, who I'm organizing this with. And I just wanted to inform you, everything is recorded, and Greg Redmond, who's also in the panel today, he's the editor, and he's also doing our website. And he will upload that as soon as possible. And you can also watch the recordings of the past sessions. And about our next session, it will be on Wednesday, December 9th. And we will discuss animals as drivers of climate change. And yeah, I hope you tune in again and have a wonderful day. And thanks to everybody. It was great. Thank you. Take care.